Unlike a good guest, the online audience is never late. Welcome to the Shine Dome. My name's Lish Fayer, and tonight we are meeting on Ngunnawal country, and I'd like to acknowledge and pay respects to the traditional owners of the land on which we're meeting tonight. And for our online audience, I'd like to pay my respects to the traditional owners on the land on which you are joining us from tonight. As we share our knowledge in this place of knowledge, teaching, learning and research practices, may we also pay our respect to the knowledge embedded forever within the Aboriginal custodianship of this country. Thanks so much for joining us again for the third in this lecture series. There's a 6-part lecture series. We kicked it off with what is AI? Then we covered AI and healthcare, and tonight, AI and the environment. Before we get started, a lecture series like this and the fabulous snacks to kick it all off, comes about from very generous event sponsors. Digital Science, I think Anthony Donor is with us tonight. Thanks, Anthony. And Pawsey Supercomputing Research Centre. Also joining us in the room tonight are series conveners, Fellows of the Academy, Professor Bob Graham and Professor Ian Chubb. Thanks for joining us, Professor Chubb. Now, we have explored the broader topics of AI, and this is where we get into the pointy end. What is AI from the environmental perspective? Now, if I asked AI, how does AI and the environment interact? Doesn't even answer. I will give it a moment. Hey Siri, tell me about AI and the environment. I think I could have asked any one of you. Still thinking, because the internet is pretty slow in here, but guaranteed AI would say that there are two sides to this coin. On one hand, you have the energy, water, resource use, along with the land, required to power these vast data centres. On the other hand, something went wrong. On the other hand, you do have the enormous potential and capability for AI to crunch numbers, to process data, to make discoveries that we would never have imagined. So balancing all of this up. Today we're going to be exploring how AI is shaping our environmental future, both as a challenge that demands responsible development and as an innovation for conservation, efficiency and science. Two fabulous speakers with us tonight. Camille Goldstone-Henry is the CEO of Xylo Systems. She's going to share how AI is being used to monitor endangered species, predict biodiversity, and also help business regenerate ecosystems. Basically, from tracking frog calls to helping corporations use nature to understand their business model, through AI-powered insights, Camille is with us tonight. Thank you, Camille. And joining us online very early in the morning is Associate Professor Chang Xu from the University of Sydney School of Computer Science. Chang specialises in machine learning and computer vision. Now, Chang will focus more on the environmental impact of AI that we often hear so much about, the future of sustainable computing, how we make the most of what we've built, and can we build not necessarily bigger systems, but smaller ones, greener ones? How do we overcome those challenges presented by AI? So that is what you're in store for tonight. And as always, questions will be welcome from the floor at the end of our two speakers. If you have a question, just raise your hand and the microphone will come to you, or there's a microphone up the top there. So let us kick it off. I think this is a great place to start because no doubt you've heard so much about the energy use of AI, but how is it actually protecting the environment? Camille Goldstone-Henry, a wildlife scientist, Camilla Roy woman, CEO of Xylo Systems, a tech entrepreneur, I'd say. But Xylo Systems is an AI platform that's revolutionising how we monitor biodiversity. And I think Camille has a specific interest in this because as a researcher, she spent weeks out in the Tasmanian wilderness, a little bit like alone, but with Tasmanian devils and a smaller camera, literally monitoring species. Boots on the ground, it doesn't get any more solid than that. But she then thought that perhaps AI tech could be involved in that grunt work and we could really compute much more as a way of protecting the environment. So Camille joins us tonight, and I'd like you to all give her a very warm welcome to a chilly Canberra. Thanks.
I want to introduce you to Hermione. She is a juvenile endangered Tasmanian devil that I helped track as part of a big conservation project. I named her Hermione after Hermione Granger, the character in Harry Potter, because like Hermione Granger, Tasmanian devils are very intelligent, but they're also very resilient. About 90% of their population was wiped out in Tasmania due to the contagious devil facial tumour disease. And so I used to spend weeks out in the rugged landscapes of Tasmania, a little bit more comfortable than the contestants on Alone. I did have quite a comfy sleeping bag and hot chocolate. But I used to spend weeks out there trapping Tasmanian devils to monitor their population and understand if it was increasing or decreasing. And that meant lugging lots of equipment to remote areas, setting chicken-baited traps, and then getting up at the crack of dawn in the freezing Tasmanian winter to check those traps to see if we got any Tasmanian devils. And from there, I'd record all of their vital statistics using pen and paper. And then I'd have to go back to the office and put all of that into a spreadsheet, and it took me forever. And it wasn't just me doing this, it was teams of scientists and volunteers and vehicles, and it required a lot of funding. And that's just to understand one species in one location. It was very expensive, it was time-consuming, and this is all in the field of conservation where funding is already scarce and stretched. And in a time when over 1 million species are at risk of extinction within the next decade due to human activity, moving at the pace of a clipboard and pen simply isn't fast enough. The way we were working was not keeping up with the scale of the crisis, with the scale of biodiversity loss that we're seeing globally. And I remember thinking, there must be a better way of doing this. In this day and age where we're using drones to fly through Iraq and just this incredible technology, why weren't we using it in conservation? I'm Camille Goldstone-Henry. I'm a conservation biologist turned tech entrepreneur. And today I'm going to share how AI is helping us finally see nature in real time and what that means for all of us. So I want to take you with me into a mangrove. It's 11 p.m. at night, you are knee-deep in mud, you're getting bitten by mosquitoes, and you're listening for a frog. And not just any frog, a rare endangered frog. And you're going to be there night on night for weeks. It's going to be quite the mission. Now, what if I told you instead of doing that, we could place waterproof recorders out in this mangrove? One that listens for us 24/7. Sounds pretty good. That's the job done. It's great, but the result is hundreds of thousands of hours of audio recording. It's impossible for a human to analyze and find that one endangered frog. But AI can do it. Each frog has a unique sound call, and it creates a sound signature. So the 3 frogs you're seeing up here are all native Australian species. You might recognise the green tree frog there that has quite a fat sound signature. So we can train AI models to learn these sound signatures. They're also called spectrograms. And the AI model then scans these hundreds of hours of audio to find when this endangered frog called. It can also tell us lots of other things. In seconds, it can tell us exactly which one of these frogs called, it can tell us when it called, and it can also tell us cool things like whether it's breeding season or not, because these sound signatures change whether they're breeding or not. So AI is really helping turn all this noise into insight. If you use Shazam, it's kind of like Shazam, but for frogs. And there's lots of other really cool use cases of AI in conservation. In Indonesia, conservationists are using AI to sort through thousands of camera trap images to find the endangered Sumatran tiger. So if you don't know what a camera trap is, it's kind of like a GoPro that you strap to a tree in the middle of the forest. And we're not just finding endangered Sumatran tigers, we're also identifying them individually from their striped marks. So we can use computer vision, or more specifically, convolutional neural networks, or CNN for short, to identify individual Sumatran tigers. We can then take that information and start to estimate the population size in real time, and we can understand whether it's declining or whether it's quite healthy. We can also use these CNN models to count elephants from space, which is my personal favorite use case of AI in conservation. So we can now combine high-resolution satellite imaging with these CNN models to identify elephants across the African landscape. And this not only tells us where they are, and therefore where we might need to be protecting habitat that we haven't protected before, but it can also help us send out wildlife rangers to protect these elephants in real time from poaching. AI in conservation is a really incredible application because it helps us hear what's too quiet, it helps us see what's too small, and it helps us move before it's too late. It's no longer about weeks waiting for wildlife monitoring results. It's real-time insights for real-time action. And now we're in this era of remote sensing. We've got drones, and we've got audio recorders, we've got satellites. We've got sensors tracking everything from birdsong to biomass. The good news is we now have more data than we've ever had before about our natural world. The bad news is we've now got more data than we've ever had about our natural world. And nature isn't simple. It's not a singular number like temperature. It's millions of overlapping data points from species records, habitats, climate layers, sound recordings, camera traps. I want you to imagine trying to bake a cake using 5 different cookbooks. They're all in different languages, and not one of them gives you the oven temperature. That's what it feels like today, trying to make decisions from this incredible biodiversity data. So it's really a benefit, but also it's a huge challenge. So the question becomes, how do we turn all of this data into action? If you want to know if it's going to rain tomorrow, you simply tap your iPhone and you get real-time, localized forecasts. You don't need a meteorologist. What if we could do the same for biodiversity? What if we could track species decline, ecosystem health, and habitat risk like we did for a weather app, but a weather app for nature? That's what AI is now making possible. Now, here's another big problem that most people aren't talking about right now. Over $69 trillion, or half of the world's economy, is highly reliant on nature and its ecosystem services. So I'm talking about ecosystem services like clean air, clean water, pollination for our crops, flood protection, and climate stability. So biodiversity loss is no longer just a conservation problem. It's now an economic problem. Yet most businesses don't even know what their impact on nature is, let alone how they rely on nature for their own operations. And it's not because they don't care, it's because nature is complicated. The data is complicated, and they've all put it in the far too hard basket. Scientists, environmentalists, and not-for-profits absolutely cannot reverse biodiversity loss alone. We really need businesses to step up to the plate. And so that's why I founded and built Xylo Systems. Because I realized we don't need AI just to track species in the wild. We also need AI to help businesses make better decisions for nature, but also for themselves. So we built this beautiful software platform that is powered by artificial intelligence. Here's how it works. We pull together global biodiversity datasets from satellite images to species surveys, government records, even citizen science records. Our AI data pipeline analyzes all of this data and then finds nature risks, habitat value, and ecosystem health. Then, and here's the real magic, we use generative AI to turn all of this data into clear insights for businesses. We tell them, here is what is at risk here. Here is what lives here, maybe koalas, maybe Tasmanian devils. Here's how you can regenerate this place to make it more resilient for your business and the community around you. We're making biodiversity something businesses can see, understand, and act on, all without needing a PhD in ecology. Let me dive a little bit deeper into that generative AI model that we've built at Xylo Systems. You've probably heard generative AI used for things like ChatGPT, chatbots, and AI-generated art. But what exactly are we using generative AI for when it comes to nature? In our case, we're turning that data into clear site-specific recommendations, mostly for property development companies at the moment. So based on all the data that was synthesized in our platform, we apply a large language model to that information, and we've adapted that LLM to understand ecological logic. So we've trained it to identify things like which species depend on which habitats, how ecosystems respond to pressures like pollution and fragmentation, and what thresholds signal a real risk for business and for ecosystems. We've also built in decision logic and prompting frameworks that reflect real-world land use works. So for example, if a site contains a critically endangered species, our platform can recommend what areas they need to conserve that could be critical habitat for that species. If it's near a wetland, for example, we apply a strict buffer zone recommendations to consider in the development of that space. And if there's potential for habitat restoration on their sites, we suggest exactly what species of plant to put there that boost ecological connectivity and ecological value. So instead of simply presenting a wall of data, which I know what that looks like here, we do have a recommendations engine, we provide a report that gives them those recommendations. And it's all grounded in science. It is always context specific, and it is always localized to their exact sites. You might be thinking, are we replacing ecologists here? And no, that is absolutely not our mission at Xylo Systems. We are not replacing science, we are simply amplifying it. Our mission is to help ecologists and sustainability teams in these property development companies to spend less time in spreadsheets and less time in numbers, and more time designing their businesses and designing their sites that not only protect species, but also regenerate ecosystems and become more nature positive. This is Duramu House at Barangaroo in Sydney. It was built by Lendlease in about 2019. And it's a really beautiful building. From the ground, it's a beautiful timber building, but what you might not know from street level is that there is an incredible green rooftop on this building. And it's a green rooftop that has been designed to support pollinators like bees and butterflies. It's right in the middle of Sydney CBD. It's quite incredible. Like many property development companies, knowing how exactly to do this, including what to plant, what species to protect, and how to actually support the local ecosystem in the Sydney CBD, you might not think there's one there, but there is, takes months of expert advice. It requires a lot of environmental reports, site-specific surveys, and it costs hundreds of thousands of dollars just to get that information to tell them how to do this. With the Xylo Systems platform, it takes them minutes and is a fraction of the cost. So our platform can actually recommend exactly what species that need to be planted here, and it's tailored to this exact site. And we have run some studies with our platform and what the ecologists suggested from this, and it is pretty much 90% accurate what our platform is putting out, which is pretty incredible. Projects like Daramu House deliver incredible biodiversity outcomes. So at Daramu House, the University of Technology Sydney ran some ecological studies on this rooftop using some of the remote sensing technologies that I've already mentioned, like camera traps, and they're also using newer innovations like environmental DNA. We're able to show that this green roof supported 9 times more insect species than the control building next to it. So there was an exact replica of the building that had no green rooftop next to Daramu House. It also supported 4 times more bird species. And not just any insect or bird species. In terms of insects, we've been able to see the return of the Australian blue-banded bee, which is quite a rare occurrence in Sydney CBD. And when it comes to birds, there were some predatory birds located at this area, which means we're now seeing a functioning trophic ecosystem being supported by this green rooftop. And it's not just biodiversity outcomes from this green rooftop. The Daramu House project also significantly cut air pollution in the building. It reduced stormwater runoff by 90%, and it increased solar output of all of the solar panels put on this roof. And this is all from a single nature-positive design. We're getting biodiversity benefits, and we're getting wider environmental benefits. Xylo Systems is allowing companies to replicate these Daramu-like impacts across their entire property portfolios anywhere in the world. This level of biodiversity planning, powered by data and delivered by AI, just simply wasn't possible before. And when it comes to combating biodiversity loss, of course the government is really important, and the Australian government is stepping up. Kind of stepping up. They've promised to set up a new independent environmental protection agency to enforce our environmental laws. And in 2023, the Nature Repair Act officially passed, creating a national voluntary biodiversity market designed to drive investment into species protection and restoration. But broader reforms to the EPBC Act, which is our key environmental legislation, have been deferred, and there's no clear timeline for rollout from the Samuel review that was conducted and delivered back in 2021. So where does that leave us right now? Yes, the government action is on the horizon, but we cannot wait for government action. We don't have time. In the meantime, companies that understand that nature is critical to the economy and their operations, all 69 trillion of the global economy, they're moving on their own. And they need tools to support that action, tools like the ones that we're building at Xylo Systems. And so the big question I posed today was, can AI help us save nature? And here's my hot take. If we can forecast the weather, we can forecast biodiversity risk. If we can track the stock market, we can track species loss. And if AI can sell you shoes that you didn't know you wanted, it can definitely help us save the planet. But here's the crux of it. AI is not going to save the world alone. People will. But AI gives us the insights, the speed, and the scale to get us there much, much faster, which is exactly what we need in this biodiversity crisis. So my take is, AI is incredible. It can help us save nature. Let's use it for good. Thank you.
So impressive. Thank you, Camille. I've written down lots of questions, but I would like you to put the questions to Camille and Chang after our next speaker. One of my questions, no, I won't ask it yet, although I want to. I do love that you didn't do yourself out of a job at all, but I do wonder, does AI bait traps with chicken now for who's doing that job down in Tassie? Students. No one's done out of a job. Thank you so much, Camille. Now, our next speaker joins us from a very early morning in the US. Associate Professor Chang Xu is an ARC Future Fellow at the University of Sydney's School of Computer Science. He specialises in machine learning and computer vision, facial recognition, but also green AI. His research focuses on developing energy-efficient AI systems, aiming to reduce that environmental footprint of large-scale computing while also advancing the AI capabilities. So with AI's continued increasing demands, as Camille has just pointed out, the opportunities are enormous. Yet how can we minimise the footprint of AI so that everything benefits, a total net positive? So please put your hands together for Professor Chang Xu.
Hi, everyone. I'm Chang Xu from the University of Sydney. AI is everywhere now. It writes your emails, edits your save files, and even drives your car. It's getting really smart. Sometimes it feels like it knows us better than we know ourselves. But here is the question I want to ask today. How smart is too smart? At what point does intelligence cross a line, not just in what it can do, but in what it costs to us, to our society, and to our planet? Today, I want to take you on a journey behind the screen to explore the hidden costs of smart AI and how we might build a future that is not just intelligent, but also efficient, responsible, and sustainable. So let's begin. Now, when we talk about how smart AI is getting, we usually end up here. AI is replacing my job. It's a meme, it's a mode, and let's be honest, it's also a fear. So writers, designers, coders, teachers, everyone is wondering, what if AI comes for my job next? But don't worry, you are not alone. So it turns out AI isn't just coming for my job, it's coming for his job too. So now we are both in trouble. Equal opportunity disruption, right? And honestly, between me and my boss, I think probably AI might work for me. But here is the serious bit. All this AI power, it doesn't come free. While we are busy worrying about jobs, something else is quietly sleeping under the radar: energy. So let me show you what I mean. So here is the question we should be asking. How smart is too smart? I mean, we love these big models, the ChatGPT, GPT-4, and others. But how much energy does all that brain power actually take? Well, training one of these large models, it can consume enough electricity to power a high-efficiency fridge for over 3,800 years. That's right. We built something so smart, it could write a novel, and so hungry. It could outlast your entire kitchen appliance lineup for several millennia. So yes, it's smart. But it's also a little excessive, and this is just the training. We often think the real cost of AI is in the training. But surprise, it's not just the model getting smart that's expensive. It's the model being helpful. Running ChatGPT every day for 1.7 billion users, that could emit over 21,000 tons of carbon dioxide a year. How bad is that? Well, we can take a simple comparison with Google search. One Google search emits about 0.0003 kilogram of carbon dioxide. But a single ChatGPT query, roughly 10 to 100 times more. So when you ask ChatGPT to write a poem about your cat, that moment of inspiration is booming a lot more than your daily web search. Now here is my favorite quote, straight from the CEO of OpenAI. So he said, saying please and thank you to ChatGPT is costing us millions in electricity. Yeah. So politeness is not carbon liability. We used to say manners cost nothing, but now a single please might cost a few extra watts. And if 100 million people are being applied at once, well, that's a whole solar farm gone. This sounds funny, and it is. But it also tells us something deeper. AI isn't invisible. Every interaction has a footprint. So where does that leave us? Are we doomed to choose between the intelligence and the electricity bills? Not necessarily. There is a movement gaining momentum across academia and industry called green computing. The goal is simple: build AI systems that are smarter but also cleaner. That means models that deliver results without frying the planet. Let's take a peek on the hood. Today's AI is powered by deep neural networks. Deep neural networks are revolutionizing computational representation of high-dimensional semantic manifolds. That's a very complicated explanation. So let me explain it in the way I explain it to my wife. You give the AI a picture, it doesn't see a cat, it sees pixels, numbers, rows and rows of numbers. The first layer might say RCHs, the next maybe some 4, then two triangle shapes may be ears, and layer by layer, like peeling an onion in reverse, the network gradually builds up an understanding this might be a cat, just like our brains do, but with more GPUs. Let's go back to that cute little cat you saw earlier. Looks simple, right? But here is the thing, what you see, that's just the tip of the iceberg. Hidden underneath are millions of parameters, layer upon layer, from edges to textures to shapes, until eventually the model says, "Hi, I think that's the cat." It's a kind of magic, except the magic runs on power-hungry GPUs in massive data centers. So if this is what one simple prediction looks like under the hood, imagine what happens when you scale it up. Actually, you don't have to imagine. AI has already been doing it for many years. I'll give you a state of the modern AI research. So for years, we have been in a committed relationship with scaling up, more data, big models, more compute. It was the default. If it wasn't working, just add another billion parameters. But lately, something has changed. AI has got its eye on something new, that is scaling down. Smaller models, faster inference, less power, same brain, smaller footprint. So we talked about AI's wandering eyes toward scaling down. Let me introduce you to what that actually looks like. Here is the traditional model, bulky, loaded, expensive to run, needs a supercomputer just to get out of bed. Now, here is a new version, same intelligence, but lean and efficient. We have put it on a green diode. Okay, so how do we actually make AI greener? Here are some most useful tools in a green AI toolbox. Pruning is like trimming dead branches of a tree. So we cut out the parts of the model that are not contributing much, so it runs faster and cleaner. Quantization, that's like replacing heavy bunking parts with lightweight materials. We use fill bar bits to represent the same numbers, saving memory and energy. Distillation is my favorite. It's like a teacher training a student. The big model learns everything, then trains a smaller model to behave the same way, just more efficiently. Compact networks are architectures that are born efficient, not just made efficient later. So you can think electricity bikes versus converting your SUV. Neural architecture search. It helps us find the best design automatically. It's like letting AI design itself, but with energy use in mind. And finally, factorization. That one sounds scary, but it's really just breaking the big calculations into smaller chunks. So together, these techniques help us build models that are faster, lighter, and much greener without giving up their intelligence. So once we have made our models slimmer and greener, what next? That's when we can scale out. Not just smart models, but smart everywhere. Phones, smartwatches, electricity meters, traffic cameras, even your rice cooker. Scaling out means we are no longer limited to giant servers in faraway data centers. We bring intelligence closer to where it's needed, on devices, on the edge, in real time. And this isn't just theory. In our recent paper at ICML, titled AI Scaling from Up to Down and Out, we laid out a framework for this exact transition. We argued that AI should not only grow up in size, but also learn to scale down in cost and out in reach. Because the future is not just about building big models, it's about building better, leaner, wide-reaching intelligence. Now, let's move from ideas to actions. Imagine a Google-like search engine, not for documents, but for neural networks. You tell it, I need a model for pedestrian detection running on these devices. And boom, out comes a list of efficient candidates. So you select a few, deploy them instantly, and compare their accuracy and speed. No long training cycles, no guesswork, just plug and play intelligence. So we call this neural architecture retrieval, a step toward truly accessible and scalable AI. Now, picture this inside a car. This is our smart cockpit demo. We have developed compact real-time models that analyze passenger status. Are they awake, distracted, signaling anything? It can recognize gesture, track posture, monitor engagement, all using lightweight AI running on automotive-grade chips. So this is where green AI meets real-time safety without draining your car battery. So let's switch the gears to connectivity. So this is the Lumina, our efficient and unified framework for high-quality image generation. It takes text and outputs images at higher resolution, beautifully aligned with the prompt. So you describe the image in language, it gives you the image exactly that. But what makes Lumina special here isn't just the image quality, it's how efficiently it works, even on limited compute. And finally, let's talk about touch. This is a single general purpose model controlling a dexterous robotic hand, which how it adapts to different object shapes without retraining for each case. So this kind of embodiment demands real efficiency. You cannot afford bloated models when you are running real-time motion control on embedded chips. Green AI here literally means smart motion with smaller models. Today, I have mostly taken you through the algorithm side of green AI because that's where we have made the biggest stride so far. But green computing is much more than just algorithms. We need smarter, more efficient hardware to run these models. And we need applications that truly matter, not just generating cat picture, but solving real-world, low-carbon problems. Because the end goal isn't just a smart AI, it's a smarter planet. The path to net zero by 2015 won't be paved by policy alone. It needs engineers, researchers, and builders like us. But let's zoom out for a second. Where are we in the grand journey of AI itself? So right now, we are still in the middle between narrow intelligence and artificial general intelligence. So the artificial superintelligence, that's still science fiction. But if we do get there, if we truly build general or superhuman intelligence, then the question won't just be what AI can do. It will be how it does it, and at what cost. So when we say we are just on the way, it's not just about AI's technical pace, it's about the values we carry on that pace. Because intelligence without responsibility isn't progress. Let's make sure that as AI gets smarter, we also make it greener, fairer, and more human. Thank you.
I'd like to see Chang. Thank you so much, Associate Professor Chang Xu from the University of Sydney. He's disappeared, but I know he's there. I'm not sure if he has woken up for us tonight or he's still awake, but what a fascinating discussion. Now I'd like to welcome back up to the panel up here, Camille Goldstone-Henry from the Xylo Systems, and we might just get...
Hi. Hello?
Oh, there he is. Thank you. Behind you, no. Chang,
Yeah.
It was absolutely fascinating. And I know so many people in the room and online would love to ask questions to both you and Camille. My question is, like with the cat scenario, is it smart enough to solve that Schrodinger's cat thing? Can it detect if the cat is or isn't in the box?
Yeah, I think for the simple cat, like image recognition, the AI cannot quite easily handle them. And in the AI and machine learning field, we currently care much about the high-level understanding about the images, and we want the AI to achieve the reasoning, just like the capability we humans have. So that would be the next challenge we want to address.
Thank you. Now I'm going to throw it out to anyone wanting to ask a question to Camille or Chang tonight. If you'd like to ask a question, just raise your hand. If you're upstairs, there is a microphone stand just to the front of the curve. If anyone online would like to ask a question, we have got a QR code on the screen, just scan that. And also if you're just not comfortable having the microphone, put that question to Dan and we'll read those out if we get time. Let's kick it off with your question.
Yes, hello, and thank you for your talks, they were fabulous. I guess I would like to ask both of you, is there much of a chance that AI might be like a cane toad, where it spreads uncontrollably to places it was never meant to be, and we look back and think it does more harm than good?
Ooh, that's a big question. I mean, I like to remain optimistic when it comes to AI, and I like to see the best in humanity and believe that we will use this tool for good. So I don't think it will become like a cane toad. I think we're already seeing examples of how AI is being used for bad. To make sure it remains being used for good, I think we need a couple of things. We need ethics and regulations around who is building AI and what it's capable of. And we really need our government to step up to enforce compliance around AI, not only AI development, but AI implementation.
Chang?
Oh, yes. So I understand the concerns about the misuse of AI technologies, but what I can say is that as AI researchers in the field, we do realize the importance of the alignment of the regulation of the AI technology. So we have developed many algorithms that will regulate or audit the response by the large language model, by the ChatGPT or other models to make sure the value that has been released by that represented by the large language model can well be aligned with the human's values. So that's actually an important area in the AI community.
Thank you.
Oh, two, that was good. Your 90% sounded excellent, but is there any way, or do you have any way at the moment of trying to get rid of that 10% without huge amounts of electricity?
It's a good question, and let me put in context for you. We're still an early stage startup, so our own resources are limited when it comes to really testing our AI capability. There are ways of getting rid of that 10% if we build our own large language models, but being an early stage startup, we just simply do not have the funding. If anyone wants to fund us in this room, we can get rid of the 10%.
Oh, we might go, yep, back there and then.
Hi. IBM say in less than 10 years that quantum computers will be commercially available. Have either of you looked into factoring what quantum computers will do for AI into any of your systems?
I'll throw that one to Chang. I have not. We haven't considered quantum computing at Xylo Systems yet, but it's something that I'm scanning and keeping in the back of my mind.
Yeah, I think quantum computing will definitely be one of the most promising techniques in the coming years. And certainly, the quantum computing can provide even more computation resources that can help us to develop for the next generation AI techniques. And meanwhile, so we can find the AI's roles and AI's influence support for the quantum computing. So AI can now help to automatically design the quantum circuits in the quantum computing field. So I can find this quantum computing field and the AI field, they can both support each other and to release even more impact.
It seems like a chicken and an egg sort of thing, doesn't it? With so much feeding the other. It'll be very interesting. Yeah, I'll keep going with questions because I think there's lots on the floor tonight. And again, please let us know, Dan, if there's any from online.
Yes, my question is for Camille. It seems now you can provide an awful lot of information to property developers or whoever requests information from you. Do you ever find that they are totally overwhelmed with everything that you tell them? Or do you actually specify which is more important?
It's a great question because the part of our work and what we do at Xylo Systems is about educating the market. There's a huge knowledge gap in a lot of the companies that we work with, so we do have to provide them a little bit of hand-holding when it comes to, even just upskilling in basic biodiversity knowledge. What is biodiversity? Why is it important for our business? Why do we need to consider it? And then work them up to, here's all the information for you and here's what's most important. Part of our platform is selecting the data sets that are most relevant for them and selecting those metrics and insights that are most relevant to the property development industry and infrastructure industry more generally. So we've already done the hard work for them in that they don't have to go out and look at all of the biodiversity data sets and ecological metrics to figure out which ones work for them. We provide that for them, and we've got white papers on that they can read through if they want to dive in as well. It's a fairly early market, so we talk about the nature tech market. It's very early and it's coming after this wave of climate technology and companies looking at their carbon footprints. And so education is inherently an important part of what we do. We find most of the companies that we work with already have some sort of biodiversity skill set, or their sustainability teams are already well versed in biodiversity, and so they understand a lot of the data that we're giving to them, but we're helping the rest of the market catch up through education and thought leadership.
Can I just follow up on that with the data? If I've learned anything from these, it's that data is king in any model. Where do you get your data from? Do you pay for it? Is it open source if it's from a university?
All of the above. So certain biodiversity data sets we can use through common licensing models. They're freely available to use for commercial purposes. Some we do actually pay for, so we partner with organisations around the world. One of the biggest ones we partner with is called IBAT, and it's a tool that aggregates a lot of the data sets from Nature Conservancy, IUCN, BirdLife International, and we pay them for their information. And we also are starting to generate our own data. So we have partnered with a Melbourne company called EnviroDNA, and they provide eDNA solutions to a lot of our customers. And that our customers ultimately own that data, but we pull that into our system and they can integrate it with our models. We don't train our models on it, but they can integrate it with our models and therefore get custom insights based on their information.
Might ask Dan just with one or two from online.
Thanks, Lish. This is a question from Bill from our online audience, a question for Camille. AI systems like software need to have models validated. What's your validation process? And the second part to that question is, have you been involved in assessment of Kosciuszko National Park and the impact on feral animals?
Good question on the validation process. It's been internal validation by our technology teams to date, so basing it off real-life projects like the Duramu use case I presented and seeing how our technology stacks up against what the ecologists put forward for that project. Our next phase is partnering with universities. So we're partnered with the University of Sydney and we're in the process of partnering with the University of New South Wales to start to validate some of our models and also develop new models. So that's coming. The second question, have we assessed Kosciuszko National Park? We have not, but we can.
I wonder if your assessment of it would be different to ecologists on the ground.
It would be interesting.
Yeah,
I mean, it's so the.
And how would you deal with that?
It's a good question, and the short answer is the data that we use is somewhat patchy. So where people are, we have really good data on nature and biodiversity, and where people aren't, we don't have very good data on nature and biodiversity. It depends on what data set we're looking at. So when it comes to more remote areas like Kosciuszko National Park, we'd kind of have to assess how much data we have in that area, and therefore if we could reliably use it for an assessment on the impact of invasive species in that location.
Question.
Great, yeah, another one from the online audience. This one's from Tony Kennedy. I think this one might be for you, Chang. He says, AI is obviously a useful tool, but very energy demanding. How can the average home user minimise energy use when using AI so that researchers like Camille can make greater use of AI?
Yes, good. I think that's a good question. So, just like the quote by the OpenAI CEO. So, saying please and thank you may cost extra energy for the ChatGPT. So that just reminds us when we interact with the ChatGPT or other large language models, try to be concise about your query. And if we can very well organize our question, and so probably the language models, they can better understand the needs. So just to minimize the interaction runs, with the language models, I think it's the tips for the daily use. And back to the business case. So actually in the literature, we have many language models ranging of the different size and also the open source models and the closed source models. So it might be difficult to deal with the closed source models. We cannot control their development. But for the open source one, we do have technologies can further to customize that open source models and to produce some much more efficient, some scaled down version that can better support the customized applications in the real world. For example, for Camille's real use.
Chang, as you were saying that, I don't know about anyone else, but often AI will come up with the first thing I see on my phone when I do a Google search. And even that, it seems to have infiltrated every part of my technology already when I do a simple search. Can you override that, for example, for Tony, so we don't have to use that, we can use our wondering for things that we probably could find out in other ways?
Yeah, I think that's good.
How do I turn it off, basically?
I think probably we need some AI that can better understand the intention of our query so that they can easily understand and to give us the exact response we expect. So that actually requires the AI to better understand the human.
Okay. We might have one more question from the audience and then online. Any from upstairs? No? We might continue down on the floor here.
So my question is, Camille and Chang, how do you stop big business from using AI to get lobbying done against the environment?
Come on.
I mean, not so much lobbying, but one of the things that we've seen in building Xylo Systems is property developers wanting to use our software to understand sort of game the system, understand where species are, particularly when it comes in New South Wales. We've got the biodiversity offsets through the biodiversity assessment methodology of the New South Wales government. They want to, and one, I will not name the name, one small developer I spoke to about 2 years ago wanted to use our platform to understand if there are certain species on his site that require logs as habitat, and so he can send someone in to clear those logs before they have to go in and do the assessments to submit to the planning authorities. So, you know, greenwashing is something that we have been hyper-conscious of at Xylo Systems, and that's been embedded in everything that, you know, we've got an anti-greenwashing statement in, you know, our theory of change. Our theory of change is how we're using technology to create the positive environmental impact that we're hoping to achieve. We've got an anti-greenwashing statement in there, and that theory of change and that statement guides everything that we build, from our technology and AI to who we sell our platform to. So we're very careful about who we sell our platform to. We've got very strict customer qualification. They have to, if we're working with a large business, they have to have aligned with the new global frameworks around biodiversity and nature disclosures, or they have to be publicly reporting nature in their sustainability report. So that's one way we're getting around that. In terms of lobbying, we're actually looking at how we can do uno reverso with environmental groups and work with them to say, okay, who are the businesses that are having the worst impact on the environment, and can we give you that data to call them out?
Chang, do you want to add anything?
Yeah. Actually, I think that's a really good question. So AI has not become an important part in our daily life, in our job. So I think what we can do is that we will have the strategic use of the AI tools that actually can improve our overall digital productivity. So that's actually the aim we want to achieve as the AI researcher. So what we are currently doing, just like I mentioned in the slides, that we focus on the scaling down. So we want to develop those quite lightweight AI solutions that can be better integrated into the existing business. And so we want to improve the overall digital productivity, so that even you use the AI, but we use the lightweight, the efficient AI solutions, the overall productivity can be improved. So I think the overall we will have some positive outcome from that.
I'll just add one more thing on your question. I mean, there is so much data that says, you know, let's take mining companies, for example, and the impact they're having on the environment. It would take some real fancy accounting for them to flip that around and saying, oh, we're not actually having that much impact, or lobby the government to be like, oh, there's really not that much harm being done. It would just be too hard. The evidence is too significant.
Great question. Thank you. Excellent answers. I think we've got time for one more question before we hit our time. Anything anyone would like to ask? Thank you. And then we'll wrap up for the evening. Another fabulous night.
Yeah, thank you. Great presentations, both of you. So double banger question for you both. What excites you about the future of AI, and what scares the shit out of you?
Maybe I can start. So I think the AI research is quite exciting, especially at the moment. So we have witnessed the intelligence emergency from the ChatGPT like big models. So, and we are going to not just to ask the AI models to write the poems, to generate the pictures, but further, we want the AI can take actions to replace the kind of heavy labor in the reality, just like the robots. So we hope the AI can be the great assistant that can help us to take the actions. So I think that's the positive part. And for the scary part, I think probably we need to think about the regulation about the AI. So we need to audit the output by the AI models to make sure the output is responsible, to be the trustworthy, not just for the ChatGPT, but also for the robot. We need to make sure the robot's action should be aligned with the human's values. I think that's the other important part we need to be careful and to pay more attention to in the future research. That's it. Thank you.
What scares me the most, and we're seeing this a lot right now, is the ability for AI to make people dumber. You know, they're using outputs of ChatGPT and Gemini that maybe aren't particularly accurate, and they're taking it as fact. That scares me a lot. We don't need AI sending us backwards. The flip side of that is it makes me really excited, because AI can also make us really, really smart if used correctly. And that makes me excited because we now have this opportunity to address wicked challenges and wicked problems at the global scale that we've never had the capacity to address at this scale before, like biodiversity loss, like climate change, like humanitarian issues. It just has huge, huge implications for us to move much faster on these issues, and I hope we continue to use it to make us smarter and not dumber.
I think that's a wonderful place to wrap up, because I think you guys are the smartest in the room and online for joining. And thank you both for such incredible insights into AI and the environment. Can we please give a big round of applause to our two wonderful guests tonight? Camille, I was thinking it's hard to hear what's too quiet, see what's too small, and help before it's too late. And I really am intrigued to see where Xylo Systems goes. If you are small now, I can see there's a big vision inside there with the smarts. And Chang, thanks so much for getting up early this morning and joining us. I think for me, it was something I think we all need to think about. Intelligence without responsibility is not progress. And it seems like all of this is, we're thinking more and more about it. So I'm going to send you all off. I'm going to be running a workshop down here on how to turn off AI on your phone. My very good colleague, who's as smart as they come down the front here, has sent me a message while I was doing that. She said, I've just Googled it, and AI overview comes up. And it says, basically, while you can't completely disable AI overviews in Google search, you can minimise their impact. You can use the ... the web filter after the doobie filter and the big filter. Basically, we'll be down here for another hour. Chang, if you could stay on the line. That's it, basically. It's not out for our jobs, but gee, we have to work hard to maintain our brains. Thank you all for coming out tonight and joining us online. Thank you to our fabulous fellows, the series conveners who make this possible and support it. And as you're going out tonight, please do tell everyone about it. You can watch it back online. It's such knowledge for our time, and that you have come out and put it into your big brains is even better. But also, appreciate the new carpet here at the beautiful Shine Dome. That colour was chosen by a human amongst a million colours they could have chosen. Beige is not just beige. And if anyone's got an idea of what the name of this colour is? Mushroom. I'll take further input than mushroom. Thank you again. Big round of applause, and big round of applause for you. And as you're leaving, remember, put in your calendar, Tuesday the 12th of August, AI and food. A wonderful conversation coming up.